All right, so now we're going to move on to example number 3. I want to determine with justification whether this series converges or diverges. Okay, no big deal. Again, I know I'm going to set up the nice limit of all of this to the kth root, or under a kth root, and it's going to be absolute valued under there. And so, of course, the thing that I'm immediately curious about is, does this thing in here that's going to be under those absolute, or inside those absolute value bars, produce negative numbers? Does it produce positive numbers? Does it produce a mixture? Like, how can I tell? Well, if I take a look down here, I can maybe start to see something like the following. I'll start by saying this. Okay, notice I'm going to leave a lot of space here, and I'm going to start my root test. I'm going to write some stuff up above this in just a moment. So I'll say that we're going to calculate that the limit as k goes to infinity of our kth root of absolute value bars 4k minus 5 over 2k plus 1 all to the power of k. If I want to start simplifying those absolute value bars, this becomes a little bit complicated. Notice that when I plug in the number 1 for k, do I get a positive result or a negative result? Well, if you actually tested it out, you could see that I get a negative number in the top of the fraction, a positive in the bottom, and I get a positive power. So I'm going to have a negative 1 to the first power. Right? Or, well, I'm going to have a negative over something to the first power. I think that first number comes out to be like negative a third if I crunch it all the way through. Okay, so that's kind of interesting. I do get a negative there. But what happens if I start to plug in values of k like a 2 or a 3 or a 4? Will I ever get negatives then? I won't. So something really awkward begins to happen here that a lot of people will sometimes incorrectly adjust for. Sometimes people will say, oh, I see that when I subtract the 5, that's what's kind of causing that numerator to go negative when I plug in the 1. And some people will incorrectly change that numerator to 4k plus 5. And then they'll say, see, now it's no longer negative. And while that's true, that doesn't mean that this formula here is going to produce the exact same numbers as that formula over there. In fact, it absolutely will not produce the same numbers. And so this is absolutely not a way that I would want to proceed. This is a terrible simplification, and I can't use it. But I could maybe go ahead and do something like this. I'm going to go ahead and note something up here at the top. I'm going to go ahead and say that we note that our series here that starts at 1 and has our 4k minus 5 over our 2k plus 1 all to the k, I know that that's equal to, and I can start to write out some of the terms of the series. Here's the first term, right? It's going to be negative 1 over 3 to the first power, so it's just negative 1/3. And then I can start to figure out what the next thing is. But I'm already kind of bored of figuring out what the things are. So really quickly, let me just re-crunch everything else together, smash it back together here in my nice series notation. Notice that the only thing I've changed here is the index. So I've kind of separated out the piece that's negative over here in the negative 1/3 from all the stuff that's positive. And now I can actually argue that we can see that the series that starts at 2 has only positive terms. So what I'm going to try to do is figure out what happens to this series. I'm not going to worry about what happens at the k equals 1 case, only what happens when I start at k equals 2. So let's take a look at this. Notice if I was going to set up the root test, the setup would actually be completely identical. Nothing would change about the setup, except that now I would know that I'm not starting k at a 1, and I only create positive stuff here. And so I know that I can actually just immediately get rid of those absolute value bars. So then I would just have 4k minus 5 over my 2k plus 1 all to the power of k. That, of course, will simplify down to now just be the limit of 4k minus 5 over 2k plus 1. And I know that if I multiply top and bottom here by 1 over k, I can change that into a limit of 4 minus 5 over k, 2 plus 1 over k, and so clearly the limit is 2, which is bigger than 1. So I have to be careful with my conclusion here. I can now say that by the root test, the series that starts at 2 must diverge. But all the way back in 5.3.1, we introduced the idea that if you were to add or delete finitely many terms to a series, you will never change convergence or divergence. So if this guy diverges, then clearly, if I just add back in that negative a third, I'm not going to change convergence or divergence. Done. Okay. So this is something that I have to make sure I'm a little careful about. While there aren't necessarily any conditions to use the ratio test, if I want to be able to simplify down those absolute value bars easily, I really need to think about how I can make those modifications. Sometimes it'll be by just adjusting things like we did in example 2, and sometimes it'll be like what we did here where I'm going to break apart a series into kind of negative stuff and positive stuff and just kind of handle one series and then tack on the extra terms at the end. All right, again, this concludes Chapter 5, and there are tons of worksheet questions that you should be able to go practice with to make sure that you are extremely well prepared for content on this. Our exam on this content won't be until after we get back, and keep your fingers crossed, hopefully we do come back, and if not, we'll cross that bridge when we come to it. If you got questions, please, of course, let me know, and I'd be happy to help.